The James Webb Telescope has been giving us some of the most amazing pictures of space. However, recently disaster struck as this expensive piece of machinery got hit by small asteroids. This could prove disastrous for the future of space research. Recently, the James Webb Telescope was hit by micrometeorites which damaged some of the mirrors on this billion-dollar piece of machinery. Well, we all know that getting hit by meteorites, no matter how small, isn't good for anyone. So, stay tuned to find out more about the degree of the damage that these rocks caused to the JWST. Asteroid strikes in May caused lasting damage to NASA's James Webb Space Telescope. Scientists disclosed just days after the telescope shocked the world with its stunning images of the cosmos. According to a publication titled Characterization of JWST Science Performance from Commissioning, the telescope has revealed issues that cannot be addressed. Additionally, they noted that the telescope experienced a minimal effect overall, which is not yet quantified. 6 micrometeorites hit the observatory, which caused serious damage to the primary mirror of the James Webb Space Telescope on May 22nd. At first, it wasn't thought to be too big of a deal, but a recent scientific article reveals it might be more serious than previously believed. The collision exceeded pre-launch projections of damage for a single micrometeoroid, spurring more analysis and modeling, the paper added. It was claimed in the paper that long-term effects of micrometeoroid strikes that steadily deteriorate the primary mirror were the biggest unknown at the moment. According to a NASA press release from June, the James Webb Space Telescope's mirror was designed to survive pounding from the space debris from its orbit of Sun-Earth L2, with dust-sized particles flying at tremendous velocities. While the telescope was being constructed, engineers used models and actual test impacts on mirror samples to better understand how to reinforce the observatory for usage in space. It went on to say that the recent impact was much more than expected and beyond the scope of what the team could have tested in the field. The publication also stated that the spaceship's mission duration was set at 5 years. Micrometeoroid hits on the mirrors and sunshield are predicted to cause gradual deterioration over time. Charged particles are predicted to cause gradual deterioration of the detectors, and the sunshield and multi-layer insulation are predicted to deteriorate due to exposure to space. The primary mirror of the James Webb Space Telescope is a 21-foot-wide golden target worth $11 billion and is largely at the mercy of space junk. The telescope is located 1 million kilometers from Earth at the second Lagrangian point, L2. That's a distance that's over 4 times greater than what separates the Moon and Earth. Because of its location between the Earth and the Sun, L2 is expected to be a comparatively clean region of space. However, the particle that smashed into C3 in May was an exception to the expected pattern of sporadic impacts with limited damage predicted by scientists. So far, 6 such micrometeoroids have impacted Webb's main mirror, or about 1 per month of the telescope's time in space, with no discernible effect. Scientists have been forced to compensate the damage to the telescope, and up to the last impact, things looked like they were in order. The telescope had an expected lifetime of 20 years, but after recent developments, scientists are unsure of its expiration date. Well, NASA truly seems unfazed by this news. The scientists behind this amazing observatory claim that its performance exceeds expectations. For what reason is Webb being held to unrealistically high standards? If it wants to achieve its ambitious scientific goals, it needs mirrors that are even cleaner than those. Its navigation system is superior to normal, as it can latch onto and follow targets. The overall quality of the images it produces is superior to what is required. Even better, Webb scientists have determined that it has enough limited fuel on board to help power the mission for the next 20 years. So, what do scientists plan to do with the Webb telescope? The first thing they are going to do is look at galaxies and stars that formed a few hundred million years after the Big Bang, over 13 billion years ago. To quote, "We are going to view the very first stars and galaxies that ever formed. You can see a lot more of the universe when you view it in infrared. Since infrared has longer wavelengths than visible light, it can more easily penetrate cosmic clouds without being impeded by their densely packed particles. At the end of the day, Webb's infrared vision will be able to see farther than that of the illustrious Hubble Space Telescope. They intend to investigate far-off exoplanets. The spectrometers aboard the James Webb Telescope will completely transform our knowledge of distant planets. Whether they are gas giants or smaller rocky worlds, the devices can determine what chemicals, such as water, carbon dioxide, and methane, are present in the atmosphere of distant exoplanets. Webb's primary mission is to study extrasolar planets outside of our own galaxy. There's no telling what we might unearth. Now, let us talk about what sort of threat can be posed by future collisions. If this impact was unusual or more prevalent than Webb scientists anticipated, only time will tell. The observatory report states, "It is not yet clear whether the May 2022 hit to segment C3 was a rare event, i.e., an unlucky early strike by a high kinetic energy micrometeoroid that statistically might occur only once in several years, or whether the telescope may be more susceptible to damage by micrometeoroids than pre-launch modeling predicted." If it turns out that Webb is more vulnerable to damage, NASA and its space exploration partners may want to consider reducing the amount of time the telescope looks in locations where there are more micrometeoroids passing through space, or perhaps turning the telescope away during specific meteor showers. Oh, and while we are on the note of the Webb telescope being amazing, let us tell you another great detail. We usually observe Neptune in deep blue tones, but in the most recent photographs from the James Webb Space Telescope, the ice giant shines with silvery light, encircled by delicate gossamer rings and wispy bands of dust. Despite the fact that no spacecraft has visited Neptune since Voyager 2 zipped by on its way out of the solar system in 1989, Webb is providing us with new, near-infrared imagery of the planet from a distance of 4.4 billion kilometers. Because of this, Neptune's appearance in the most recent Webb photos deviates significantly from its typical azure hue. The methane gas in Neptune's atmosphere appears blue because it absorbs light at the visible spectrum's longer wavelengths. On the other hand, methane gas is an excellent insulator, so much so that it appears dark gray in infrared wavelengths, or the infrared equivalent of dark gray. Webb's image processing team transformed infrared wavelengths into visible colors to obtain these photos. However, Webb's instruments detect dazzling brightness from the frozen methane ice particles in Neptune's topmost clouds because they reflect most of the sunlight that touches them. Clouds at such a great height may provide clues to Neptune's turbulent, windy climate for astronomers studying the planet from afar. Examples of telltale signs of the worldwide circulation pattern that drive the ice giant's weather include a faint, thin band of brightness around the equator. Warmer gases in Neptune's atmosphere, moving toward the planet's equator, enhance infrared photographs of the planet. Many astronomers miss Neptune's weak rings because of their distance. It is possible that these specks of dust-coated ice are all that's left of an old moon that orbited so close to Neptune that the planet's gravity tore it apart. Webb's first picture of Neptune shows rings that have never been seen previously by astronomers, as well as a fresh look at rings that haven't been photographed since Voyager 2's flyby. Triton, the largest and most peculiar of Neptune's moons, was among the 7 moons that Webb photographed. They believe that its retrograde orbit around Neptune is due to its past life as a dwarf planet like Pluto or Sedna that was captured by Neptune's gravity and forced into a backward orbit. Because its nitrogen ice shell reflects most of the sunlight that touches it, Triton seems much brighter than the planet that holds it hostage in Webb's photos, with massive diffraction spikes as if it were a nearby star rather than a moon. Webb will continue its detailed observations of Neptune and its moons over the next few months, which may reveal more about the system's dramatic past. Now, we want to keep on talking about James Webb and all the potential it has, but we have run out of time. But before we go, why don't you subscribe to our channel and hit the bell icon on your way out? Oh, and what do you think about the telescope? How long will it be able to function, especially now that we know scientists did not properly assess the risks of micrometeorites? Let us know in the comments below.